October 29, 1969. A message is typed into a computer at UCLA, but the system crashes. Only two letters make it through, L and O. Not because it was short for LOL. No, this was 1969. It was supposed to say log in. But in that moment, the modern world quietly began. Long before Google, before YouTube, before even the word internet meant anything, it all started with a military experiment. So obscure, so hidden, most people have never even heard of it. It was a secretive, government-funded experiment built during the Cold War. Not to connect friends, but to protect against annihilation. This is the story of how DARPA accidentally built the backbone of the modern world, the ARPANET. It's the 1960s. America is on edge. The Cold War is in full swing. The Cuban Missile Crisis is still fresh in people's minds. Nuclear annihilation feels like a real possibility. Now imagine you're a general at the Pentagon. You need to send an urgent message if war breaks out. But all your communication lines run through centralized hubs. Hit the hub, and the whole network collapses. That was the nightmare scenario. So the question was, how do you build a communication system that doesn't fail if a city is taken out? That's where DARPA, the Defense Advanced Research Projects Agency, came in. Their job? Solve the unsolvable. And one of their wildest ideas, build a decentralized network that could survive anything. A network where information could route itself around destruction. It was risky. It was expensive. It sounded like science fiction. But DARPA liked those odds. In 1962, a psychologist named J.C.R. Licklider was appointed head of DARPA's Information Processing Techniques Office. Licklider wasn't your average bureaucrat. He was a visionary, obsessed with the idea that computers could communicate, not just calculate. He imagined a future where everyone could connect to a vast, intergalactic computer network, and DARPA gave him the budget to try. Now, this wasn't some Star Trek fan fiction. Licklider genuinely believed that machines, if connected, could amplify human intellect and collaboration. And unlike most government officials with wild ideas, he actually had the receipts, a budget, and an entire office dedicated to pulling this off. Under his direction, DARPA started funding radical research at universities like UCLA, Stanford, and MIT, basically telling brilliant young minds, here's some money, go break stuff, preferably in a way that changes the world. At UCLA, Leonard Kleinrock was developing something called packet switching. Now back then, computers were more like lonely islands, each doing their own thing, waiting to be personally invited to the party. Kleinrock was busy rewriting the guest list. Instead of sending entire files in one long stream, you break them up into smaller chunks, packets, and send them through different paths, like putting a letter in many envelopes, sending them by different couriers, and reassembling them at the destination. It was chaotic, but it worked. That's because packet switching didn't care if one path was busy or broken. The packets would simply reroute. And with that, the idea of a decentralized, packet-based network was born. Of course, behind the scenes, this was also inspired by earlier visionaries. Paul Baran in the US and Donald Davies in the UK had independently dreamed up packet switching years before. Their ideas were radical, dense, and mostly ignored, like academic mixtapes that didn't get airplay. But someone at ARPA was listening, and Licklider gave those ideas a home. By 1969, the pieces were in place. DARPA funded a contract with a small Boston company called BBN to build the first interface message processors, basically primitive routers. They installed them at 4 locations: UCLA, Stanford Research Institute, UC Santa Barbara, University of Utah. These were the first 4 nodes of the ARPANET. On October 29, 1969, UCLA tried to send a message to Stanford. The message was simple: LOGIN. They typed the L, it worked. They typed the O, still good. They typed the G, and the system crashed. LO. That was the first message ever sent on what would become the internet. Originally, the ARPANET was supposed to be for serious military research, but researchers started using it for, well, everything else. They chatted, sent files, played games, and even shared jokes, including what some consider the first ever meme. It turns out, when you give smart people a new communication tool, they don't just publish papers, they connect. More and more universities wanted in. By the mid-1970s, the network had dozens of nodes. But this created a problem. Different systems, different protocols, different ways of talking. It was turning into digital chaos. Enter Vinton Cerf and Bob Kahn, researchers funded by DARPA, appointed to solve the problem. They realized that if the network was going to grow, it needed a universal set of rules, a protocol every machine could understand. Their solution, TCP/IP, Transmission Control Protocol/Internet Protocol. It was like inventing a universal grammar for computers. It broke messages into packets, ensured they arrived intact, and routed them efficiently. In 1983, ARPANET officially switched to TCP/IP, turning a patchwork of networks into a single, unified system. That's the moment many consider the true birth of the modern internet. Not when it became visible to the public, but when it became viable for everything that would follow. It was no longer just an experiment. It was the internet. As the 80s rolled on, ARPANET's role shrank. The National Science Foundation built its own backbone, and more commercial networks appeared. In 1990, ARPANET was finally decommissioned, but its DNA lived on. That same year, a British scientist named Tim Berners-Lee invented the World Wide Web, a way to navigate this vast network using hyperlinks and browsers. What DARPA started as a Cold War survival project became the foundation for everything online: email, websites, streaming, social media. Today, every click, every upload, every stream traces its lineage back to ARPANET. The idea of decentralized communication, of packet switching, of open protocols, those weren't Silicon Valley's inventions. They were DARPA's. In the middle of the Cold War, America's military asked, how do we survive a nuclear attack? They ended up building something far stranger and far more powerful. The internet wasn't meant for cat videos, viral memes, or billion-dollar startups. It was meant to withstand war. It began with fear and became freedom. One failed message, just 2 letters, sparked the biggest transformation in human communication since the printing press. L and O, lo and behold. If you found this story meaningful, show some love by liking and subscribing to our channel, because in every video, we uncover the inventions, the stumbles, and the strokes of genius that change the world.